Good day. I want to tell you about my free energy installation. I apologize for not knowing English and using a translator, so there may be errors in the translation. My installation is created around the Pascal hydraulic machine. If someone is not familiar with the work of a hydraulic machine, just type its name in the search and see the principle of its operation. A hydraulic machine is a primitive hydraulic jack, where when lifting we win in mass but lose in height. It consists of two cylinders of different diameters and due to the property of liquids to transmit the same pressure in all directions. We have the ability to lift a larger load in a cylinder of a larger diameter with a smaller load in a cylinder of a smaller diameter. I added a third cylinder so that the load from the third cylinder returns the piston of the first cylinder with a diameter of 50 centimeters to the upper position and starts the work cycle again. Now in more detail how my installation is arranged. My installation consists of 3 cylinders. The dimensions of these cylinders and loads can change. I will now give the dimensions that I calculated for the given installation. Let's start from right to left. The first cylinder is 50 in diameter. It has a piston with a load and the total weight is 100 kilograms. If you calculate these 100 kilograms for the entire area of the piston, then you get 51 grams per square centimeter. I will count grams per square centimeter. It is more convenient and understandable for me. The piston stroke down will be 1 meter. Therefore, we also have a hydraulic column that creates pressure depending on what density of liquid we use. For example, I will use a liquid with a density of 850 kilograms per cube. So this hydraulic column 1 meter high gives a pressure of another 85 grams per square centimeter. Before starting, I drew all the moving parts of the installation in red and their final position in green. The second cylinder is 1 meter 50 centimeters in diameter. It has a piston on which a reservoir with liquid is located on legs and a diameter of 2.5 meters. This liquid is not physically connected with the liquid under the piston and has a density of 1 ton per cube. But this density can be changed later. I will explain why. The total weight of the piston with the reservoir and liquid is 900 kilograms, but you can take a larger weight later. I will explain why. Also above the reservoir there is a fixed part on which the reservoir will be mounted so that the liquid from it is displaced into the third cylinder with a diameter of 70 centimeters. Between the movable reservoir and the fixed part there will be a seal or a rubber joint that will close the space between them and will allow first to displace the liquid into the third cylinder and then during the return stroke will create a vacuum and will suck the liquid back into the reservoir. If the piston stroke in the cylinder is 50 centimeters 1 meter down, then the displaced liquid from it will lift the piston in the larger cylinder up by 11 centimeters. And the piston will lift the reservoir with a diameter of 2.5 meters onto the fixed part and displace from there liquid in a volume of 539 liters into the third cylinder through the tube that connects them. The third cylinder has an internal diameter of 70 centimeters. In the cylinder there is a float with a diameter of 65 centimeters, which when it rises to the upper position will become a counterweight and through the cable will engage with the piston in the cylinder with a diameter of 50 centimeters and return the piston to the upper position to start the cycle again. This float weighs 330 kilograms and is already immersed in liquid by 1 meter and is in a floating state, and when the liquid comes from the reservoir into the cylinder, the float will immediately begin to float up. At the bottom of the float there is a valve with a diameter of at least 30 centimeters to which a cable is attached. The cable through the hole at the top of the float through the rollers will catch up with the piston with a diameter of 50 centimeters, and when the piston reaches its almost lower position, it will engage with it to open the valve and allow the float to sink. Since the displaced 539 liters will lift the float by 1 meter 40 centimeters, and the piston in the 50 centimeter cylinder has a stroke of 1 meter, the cable will catch up with the piston, engage with it, and as soon as engagement occurs, the float will rest against the limiter and stop moving up, but the piston from the first cylinder will continue to move down a little more and pull the cable, which will lead to the opening of the valve in the float. After the valve opens, the float will lose buoyancy and begin to move down. The liquid around the float will begin to flow inside it through the open valve. It will flow inside by 17 centimeters. Nothing prevents the liquid from flowing in, since there is a hole in the float at the top and the air will be freely displaced. Since the float has now become a counterweight for the piston from the first cylinder and is engaged with it, it moves with the piston in the same way. Sorry, I'll repeat it again. When the piston in the first cylinder goes down 1 meter, it will start to lift the piston in the second cylinder up 11 centimeters, and the piston of the second cylinder will lift the reservoir from which the liquid will flow out in the volume of 539 liters into the third cylinder. After the liquid flows out, the weight of the piston with the reservoir will decrease from 900 kilograms to 361 kilograms, which will allow the piston of the first cylinder to maintain an advantage in pressure on the liquid, and the liquid from the reservoir, moving into the third cylinder, will lift the float by 1 meter and 40 centimeters, which will allow the cable to catch up with the piston of the first cylinder and engage with it, and the float, resting against the limiter, will stop after engaging, and the piston of the first cylinder will go down and pull the cable and open the valve, and the float will begin to sink, pulling the piston of the first cylinder up, and will begin to return it to its initial upper position. Yes, liquid will flow into the float, but since the float is hooked into the piston, it will travel the same distance with it, and the liquid under the float will begin to flow into the reservoir, which is above the piston of the second cylinder, faster, since the liquid during the stroke of the piston of the first cylinder and the float by 1 meter leaves at a speed of 1 meter 40 centimeters. After the float begins to sink, the piston of the second cylinder will go down, and the reservoir above it will also go down and create a vacuum, which will begin to suck liquid from the third cylinder into the reservoir. Therefore, when the float goes down, lifting the piston of the first cylinder up, then after half a meter the liquid under it will be lower than the float, and the liquid will simply flow out through the open valve. When the float goes down a meter, it will return the piston to its original upper position, and the piston of the second cylinder to its original lower position, and the liquid from the third cylinder will return to the reservoir by vacuum. When the piston of the first cylinder reaches the upper position, the engagement device will rest against the limiter and will be unhooked, which will lead to the return of the device to its original position. Also, after unhooking, the float valve in the third cylinder will close and it will again become floating, so that it does not jump into the liquid under it. Some shock absorber or limiter will meet it, and the unit is again ready to repeat the work cycle again. According to my calculations, it should do at least 2 such cycles per minute. And if a hydraulic motor or other mechanism is placed in the tube between the first and second cylinders, then it is possible to transfer energy to the flywheel and from it to the generator due to the movement of liquid between the cylinders. After all, the liquid will pass between the cylinders under good pressure and is easily capable of spinning a flywheel weighing at least 60 kilograms. I have now considered only the very possibility of the device's operation, and not its efficiency. For example, if you take a liquid in the reservoir above the second cylinder of greater density, you can increase the weight of the float in the third cylinder. It is also easy to increase the volume of liquid in the reservoir above the piston of the second cylinder, simply by increasing the diameter of the reservoir, which will make it possible to increase the diameter of the third cylinder and the float and the mass of the float. After all, I slightly changed the operation of the hydraulic machine, and now when the piston of the second cylinder rises, its weight decreases, which allows you to not follow the rule when the weight above the pistons of the first and second cylinders is equal to the difference in their area. And this free energy installation is very reliable and allows you to work for decades with little maintenance, since the liquids under the pistons lubricate them and there is almost no wear. Also pour a little liquid on top of the pistons. Yes, the rubber connection between the moving part of the reservoir and its fixed part above the piston of the second cylinder is subject to wear due to frequent bending, but is still capable of working for a long time. And with mass production, this installation will be inexpensive. Also, its operation does not depend on weather conditions. If someone finds errors in my calculations, I am ready to discuss it, but I am confident in the operability of the installation because it was created in compliance with all the laws of physics. Yes, I do not have the financial and technical capabilities to assemble a prototype, at least in smaller sizes. And if someone wants to assemble it themselves for scientific purposes, they can do it. And in the description of the video there is my PayPal if someone wants to participate. You can show this video to those who are well versed in physics and mechanics, and I am sure if they consider this installation, they will confirm my calculations. Thanks to everyone who watched this video, put a like, and if you saw an error and think that the installation will not work, I am ready to discuss this with you in the comments.